Okay, let's unpack this. Picture this for a second. You're about to build something incredibly intricate. Something with thousands of moving parts, massive machinery, complex logistics, basically. Something like a state-of-the-art car factory.
Right. A huge undertaking.
Exactly. Now, what if you could actually build that entire factory and test it, simulate every single robot's movement, check every part's journey, validate every clearance, all of it in perfect detail,
Okay.
but without ever laying a single physical brick or, bending one piece of actual steel? Imagine running decades worth of complex physical processes, but doing it in just a few days.
That sounds like the ultimate engineering sandbox, doesn't it? Like
Yeah.
a massive leap beyond just standard blueprints or limited simulations.
Totally.
It's really the promise of taking these powerful digital tools and applying them to, well, arguably some of the most complex physical environments we have.
And you know what? It's not science fiction anymore. That's exactly the really fascinating topic we're diving into today. We're going deep, really deep, into a significant strategic move by the BMW Group.
Ah, BMW. Okay.
Yeah. They're not just like tinkering with creating digital replicas of their factories. No, they are actively industrializing and scaling something they call their virtual factory.
Industrializing and scaling. Those are the key words. So our mission today for this deep dive is really to get under the hood of that. What does this virtual factory idea actually mean in practice for a huge global player like BMW?
Right.
Why is it suddenly such a critical piece for their massive production network? What's the clever tech making it tick? And crucially, what are the real measurable benefits they're seeing now or expecting down the line?
Exactly. And this isn't just, tech buzzwords for the sake of it. This is fundamentally about changing how they tackle the incredibly complex physical stuff involved in planning, validating, optimizing, basically making millions of cars every year across, dozens of global sites.
It's a massive operational puzzle.
It really is. And our source, our guide for this exploration, is a pretty detailed press release that came directly from the BMW Group. It lays out their whole strategy and the specifics of this initiative.
Okay, good. So let's start right there. When BMW uses that term, virtual factory, what's the core concept? What are they actually building or creating?
Well, it's way more than just, say, a single 3D model of one specific plant. Companies have been doing variations of that for a while, right?
Sure, basic CAD models and layouts.
Yeah, but the source makes it really clear. This is about creating and using these highly detailed, dynamic digital twins of over 30 of their global production sites.
Over 30. Wow, okay.
Yeah. So think of it like building a really comprehensive, living, breathing digital copy for almost their entire worldwide manufacturing footprint. It's about mirroring that complex physical reality in a persistent digital space.
And I think the most powerful words you use there based on the source aren't just creating, but industrializing and scaling.
Exactly.
That tells you this isn't some side project in an R&D lab or, just one pilot plant they're testing. They're baking these digital twins right into their core operations. It's becoming a standard essential tool for how they plan and work across that huge global network.
That's it. It signifies a really deep strategic commitment, doesn't it? A major operational shift. And at scale.
Absolutely. They're embedding it deep into the day-to-day workflow, specifically for production planning.
And the source also explicitly calls this virtual factory a core element of their bigger picture strategy, the BMW iFACTORY. Now, when you hear iFACTORY, especially alongside mentions of digitalization and efficiency goals, what does that suggest the overall aim is?
Well, based on that context, the focus on digital, lean, efficient, maybe even sustainable production iFACTORY sounds like their blueprint for the future of manufacturing.
Makes sense.
Yeah, it points towards operations that are, intelligent, super connected, highly efficient, transparent, adaptable, all those good things.
Wow.
And the virtual factory, being this digital double of the physical sites, well, it's clearly the foundational digital backbone that makes a lot of those goals actually possible.
Ah, okay. It's the platform.
It's the platform where they can simulate, test, optimize, validate everything in the physical world to align with those future production ambitions.
Okay, so let's recap slightly. We've got these detailed digital twins of over 30 sites. They're industrializing and scaling this across the whole network. And it's a core part of this future iFACTORY vision. So what's the main goal? What's driving this massive scaling effort right now? Why the big push?
The source is really unambiguous about that. The number one objective, the core mission, is to accelerate production planning worldwide.
Accelerate planning.
Yeah. Think about traditional manufacturing, especially in complex industries like automotive. Bringing in new products, changing lines, making big process adjustments. It usually involves a ton of physical trial and error.
Right. You have to actually move machines, test with real parts.
Exactly. You're physically moving things, running tests with actual equipment, making manual tweaks right there on the factory floor. And that process is incredibly time-consuming. It costs a lot of money, and it disrupts the ongoing production.
Yeah, you can't be building cars while you're testing the line setup.
Precisely. So the virtual factory is explicitly designed to dramatically cut down or maybe even eliminate a lot of that physical trial and error phase. You do the heavy lifting, the planning, the validation, the optimization digitally first.
Okay, and you, the listener, might be thinking, all right, BMW is scaling this cool tech, but why does this matter to me? Why is applying this across dozens of locations a big deal?
Well, think about the ripple effects. When a company operating at BMW's scale industrializes something like this, it means those benefits. The faster planning, the cost savings, the agility, the reliability in launching new models, they're not just happening in one or two special places.
It's everywhere.
It's potentially across their entire manufacturing system. And that directly impacts things like how quickly they can get new car models integrated into different factories around the world, maybe even simultaneously.
Which could mean faster time to market.
Could mean faster time to market, absolutely. It influences the overall efficiency of how they build cars, which down the line can affect availability, maybe even the cost structure, and just how quickly the company can respond to what the market wants. It's fundamentally about building a much more agile, efficient, and robust global manufacturing engine from the ground up digitally.
That makes a lot of sense. So they're building this incredibly sophisticated digital layer, scaling it globally. But what's the immediate trigger? Why this urgency now? And what are the really striking benefits they're hoping to get from this scaled-up virtual factory?
Well, the source lays out a very clear, very immediate challenge BMW is facing. They are gearing up to integrate a massive number of new or significantly updated vehicles into their global production network. We're talking more than 40 different models or updates between now and 2027.
Wow, 40 in just a few years.
Yeah. Just wrap your head around the sheer volume and complexity of managing that many product introductions and changes across, 30-plus plants at the same time.
That's staggering.
It really is. Each single integration needs meticulous site-specific planning. How does the new model physically fit on the existing lines? What equipment needs changing or upgrading? How do you optimize the flow of thousands of parts? How do you train people on the new steps? It's a colossal logistical and engineering headache multiplied across their entire network.
40 new vehicles or updates.
Yeah.
Yeah, that's not just a little ripple. That's like a tidal wave of integration work for their planning teams.
Absolutely. And the source specifically points out that this virtual factory capability is being deployed and used first and foremost for these upcoming integrations. The explicit goal: to ensure immediate stability at the plants during these incredibly complex, high-stakes launches.
Stability. Why is that so crucial during a launch?
Well, launching a new model is super delicate. Any hiccup, say, a physical clash between the new car body and an existing robot, or a miscalculated path, or a bottleneck in parts delivery, it can bring a whole production line grinding to a halt.
Which costs a fortune.
Exactly. These disruptions are incredibly expensive. Lost production, potential quality issues, delays getting cars to customers. It's bad news all around. So, by doing all the detailed integration planning and validation virtually beforehand, they can spot and fix these potential problems in the digital world where fixes are, fast and cheap.
Before they ever risk messing up the physical production line.
Precisely. Iron out the kinks digitally first.
Okay, so ensuring stability during these, frankly, numerous and complex launches is a huge near-term win. But the source mentioned an even bigger, sort of more quantifiable potential benefit, right? Something about efficiency gains.
Yes, and this is where the potential financial impact really comes into focus. The projection is that the virtual factory will lead to a reduction in production planning costs by up to 30%.
Up to 30% reduction. Okay, for a global manufacturer like BMW, cutting 30% from a core operational cost like production planning, that's not small change. That's massive.
It's a huge figure. It represents a really significant potential strategic advantage.
And thinking about how this tech works, based on the details in the source, where do you think those savings actually come from? How do they get to that 30%?
Well, the source points to a few key areas. A big one is just avoiding those costly, time-consuming physical trials and validation steps, like that collision check example we need to talk more about.
Right, the manual checks.
Yeah. Also, reducing the amount of rework needed on the actual factory floor because you caught and fixed issues virtually. Then there's better optimization of really expensive resources. Think about physical space, machinery, even personnel time, planning it all optimally before you spend the money or make the physical changes.
Makes sense. Less waste.
Less waste, fewer disruptions to the existing production lines that would normally be needed for testing. So when you add up all those efficiencies across the planning needed for, 40 new vehicles going into 30 plus plants, that 30% reduction starts to seem pretty achievable and obviously very impactful financially.
And it's probably not just about the direct cost savings either, is it?
Yeah.
I mean, accelerating the planning itself, which they said was the main goal, must have other knock-on benefits.
Oh, absolutely. The cost number is eye-catching, for sure, but faster planning cycles mean greater agility. They can react more quickly to market shifts, maybe incorporate design changes later in the process, and just generally get new products out to customers faster.
And what about the people, the planners themselves?
That's another key point. It likely frees up their highly skilled human production planners from some of the more tedious, manual, repetitive checks and tasks that the digital twin can now handle, maybe automatically or semi-automatic.
So they can focus on harder problems.
Exactly. It lets those human experts concentrate on the higher level stuff, complex problem solving, strategic thinking, optimizing things in ways that maybe still need human insight and creativity. The tech becomes a tool that enhances the planner's abilities rather than just replacing them.
Okay, so for you, the listener, whether you're into manufacturing, engineering, logistics, or just how big companies work, think about the sheer scale of launching 40-plus new products globally. This virtual factory thing isn't just a fancy simulation. It's a fundamental change in how BMW tackles that massive challenge.
Right. It's designed to make it faster, cheaper, and way more reliable by shifting the bulk of the really hard planning, validation, and optimization work into the digital world first. It's leveraging seriously cutting-edge tech to solve some major industrial puzzles.
And none of these potential benefits would even be feasible without a really sophisticated technology foundation underneath it all, right? You mentioned earlier, these aren't just static 3D models.
Yeah.
How do they actually build these functional digital twins?
Yeah, the source talks about intelligent linking of different kinds of data. That seems to be the key. The real power isn't just having the data itself, but how it's all connected and integrated to create this dynamic, representative digital copy.
Okay, so what kinds of data are we talking about? What gets linked together?
The source gives us a good breakdown. First off, you need the basic building data. That's the accurate physical layout of the factory itself, walls, floors, columns, the fixed structures. You need the virtual shell.
Got it. The container.
Then, absolutely critical, is the equipment data. This is super detailed info about every piece of machinery, robots, conveyors, presses, welding stations, paint booths, you name it.
What kind of detail?
Their exact dimensions, how much they weigh, precisely how they can move, their reach, their speed, all their technical specs. Without accurate models of the equipment, your simulation just won't match reality.
Makes sense.
Right.
What else?
Then there's intricate logistics data. This is all about how materials and parts flow through the factory. Where do things arrive? How do components get delivered to the line? What paths do they take? The timing, storage locations, the sequence of operations. Simulating logistics is key to making sure parts get where they need to be exactly when needed without causing jams or delays.
Okay, buildings, equipment, logistics. What about the car itself?
Yes. Obviously, central to planning for new products is the detailed vehicle data. This means the precise dimensions, the 3D shape, weight distribution, specific connection points for handling, all the geometric and structural details of the new car model that's going to be moving through those lines. It's the thing they need to process within the digital twin.
And they mentioned something else, too, something about people.
Yes, and this is really interesting because it shows the level of detail they're aiming for. They also include 3D simulation of manual work processes.
So simulating the human workers.
Exactly. It's not just about the robots and the cars. They create digital representations of the human operators and simulate the exact movements and interactions they have with the product and the equipment on the line.
Why simulate the people?
Well, it's crucial for things like optimizing ergonomics, making sure the workstations are comfortable and safe, for efficiency, finding better ways for people to do their tasks, for safety checks, identifying potential risks, and even for developing realistic training programs within that virtual environment. It brings the human factor into the detailed digital plan.
Wow. So linking all that buildings, equipment, logistics, vehicles, even human actions, That's what makes it a dynamic, functional digital twin for simulation.
That's the idea. That integration is what gives it the power.
So where do they actually run these complex simulations? Where does all this linked data come together? The source mentioned the environment they use.
Yeah, they describe it as an industrial 3D metaverse application. Using the word metaverse there is pretty interesting.
Also,
It suggests it's more than just like opening a simulation file on one computer. It implies a persistent, shared virtual space, a digital environment that accurately mirrors the physical factories, and that different teams can access and use collaboratively, like a shared virtual workshop for planning.
and they actually named the specific tech platform, didn't they?
They did. They mentioned NVIDIA Omniverse as the base for this industrial 3D metaverse application. And NVIDIA, of course, is a big name in high-performance computing and simulation tech needed for this kind of heavy lifting.
Right, you could need some serious horsepower for this.
Oh, definitely. Building and running simulations with this level of fidelity, integrating all those data types in one 3D space, it takes massive computational power and a really robust platform.
And the source highlighted a key capability: doing simulations in real time. Why is real time so important here versus, say, running a simulation overnight and getting results the next day?
Real-time capability completely changes the workflow. It allows for immediate feedback, instant iteration. A planner can go into the virtual factory, make a change, move a machine, adjust a robot's path slightly, alter how the car moves, and instantly see the consequences.
You see the result right away.
Right away. Does it fix the problem? Does it create a new clash somewhere else? You can test really complex, dynamic scenarios with multiple robots, vehicles, maybe even simulated people moving at the same time, and just watch how they interact, almost like watching the real factory floor.
So it speeds up the trial and error dramatically.
Exponentially.
Yeah.
Compared to waiting hours for batch simulations to finish, this lets planners explore different options much faster, fine-tune everything much more quickly.
So using these real-time simulations of the digital twin, what specific parts of the factory are they actually optimizing virtually?
The source mentions the core stuff. Layouts, figuring out the absolute best arrangement for equipment, workstations, pathways on the floor, robotics tuning the exact paths, the timing, the coordination of maybe dozens of robots working together, making sure they're efficient and don't crash into each other, and logistics systems, ensuring that smooth, efficient flow of materials to the line, minimizing travel distances and avoiding bottlenecks.
Perfecting it all digitally before you touch anything physical.
That's the goal.
And what about the future? They hinted at AI, right?
Yeah, that was a particularly forward-looking bit. They mentioned continuously expanding the system to include generative and agentic AI functionalities and assistance.
Okay, generative and agentic AI. What might that look like in this context?
Well, the source doesn't spell it out in deep detail, but we can make some educated guesses. Generative AI, maybe it could help the planners by automatically suggesting several different layout options based on constraints. Or generating optimal robot paths as starting points, kind of like a creative assistant.
Okay, and agentic AI.
Agentic AI could potentially act more like, well, intelligent agents within the simulation. Maybe they autonomously monitor simulations to flag potential collision risks or efficiency problems that a human might overlook. Or perhaps they could even simulate autonomous transport robots navigating the factory twin. It suggests the digital twin is evolving from just a passive simulation tool into something more active, more intelligent, maybe even a partner in the planning process that can suggest solutions.
So for you listening, this is really where cutting-edge tech hits the factory floor, isn't it? It shows how gathering tons of data, linking it smartly, running powerful real-time simulations, maybe layering in AI.
Yeah.
It creates this incredible virtual sandbox.
Exactly. A sandbox where they can effectively build, test, run, and perfect the physical factory and all its intricate processes before they commit time and money in the real world. It's literally like running the factory digitally first to make sure it's right.
And to make this powerful, maybe slightly abstract idea of a digital twin really concrete, the source gives us a perfect, practical example: the automated collision check for new car models.
Ah, yes, the collision check. This is absolutely fundamental. It's a non-negotiable step every single time a new vehicle gets introduced onto a production line. You have to be certain that the new car body, with its unique shape and size, can physically pass through every single stage of the process without hitting anything, the existing machines, building structures, other stuff.
It sounds obvious, but critical.
Yeah.
And the source really drives home the value of the new virtual way by contrasting it with the old way, which they actually described as painful.
Painful is a good word for it. Based on their description, it really highlights the efficiency gain. In the past, doing this check meant you needed a real physical vehicle body, not just a drawing, an actual metal
The
shell.
real car body.
Yep. And then this physical body had to be slowly, painstakingly, manually guided inch by inch, foot by foot through the entire production line where it's going to be built.
Manually. That sounds slow.
Incredibly slow. The source specifically says this often took place over several weekends.
Weekends. So shutting down production lines just for this.
That's the implication. Significant disruption. Lines that should be building cars are instead being used for this manual validation process. And they give a really vivid example from the paint shop. To check clearances there, where car bodies go through tight spaces and get dipped into huge tanks,
Right.
the old way could mean they had to completely empty and clean out those massive dip coating tanks used for priming.
Empty the whole tank.
Empty and clean it. These are enormous industrial vats. It's not like pulling the plug on a bathtub. It's a huge, complex, time-consuming, expensive job, adding even more disruption just for this manual check.
Okay. Taking a real car, guiding it manually, often over weekends, disrupting production, maybe emptying giant tanks.
Yeah, I can see why they called the old method enormous in terms of cost and time. A necessary evil, maybe, but definitely painful.
Exactly. Now, compare that to the new method using the virtual factory. The source describes it, quite proudly, as digital, automated, and fast.
Okay, so how does it work digitally? They take the detailed, precise design data, the CAD model of the new vehicle, and combine it with super accurate 3D scans of the actual production line environment. So they capture the real as-is state of the factory.
Merging the design with the real-world scan.
Precisely. Then, inside that industrial 3D metaverse, the system runs a very precise, automated simulation. It simulates the vehicle moving, rotating, everything through the entire line exactly as it would physically. And the key part is, the system automatically checks for potential collisions at every single point along that simulated path, down to very fine tolerances.
Okay, digital, automated, and fast. This is where that killer statistic comes in, right? The time savings.
This is it. The source reveals the truly staggering comparison. What now takes them just 3 days to simulate and validate virtually.
3 days.
Previously required almost 4 weeks of that real, physical, disruptive testing on the actual factory floor.
4 weeks down to 3 days.
Yeah. Nearly a month of painstaking physical work reduced to 3 days of automated virtual simulation. That single comparison, for me, is the core aha moment. It just makes the benefit crystal clear.
It's undeniable. It perfectly shows the practical value in time and money.
Absolutely. And when you think about why it's so much faster and less disruptive.
Well, there's no physical car to move around.
Right. No stopping the actual production line, no need to empty those giant paint tanks just for a clearance check. The simulation can run faster than real time, probably alongside other planning work, and it has zero impact on the physical factory. All those massive logistical and physical headaches of the old way just vanish.
So for you listening, that specific collision check example really makes the whole idea of a digital twin or industrial metaverse suddenly feel very real, very tangible.
Exactly. You can picture that old, slow, costly process and then immediately see the huge practical advantage of doing it digitally. It's probably the best single illustration in the source of how this simulation tech pays off in the real world.
And the power of this whole platform, this virtual factory, isn't just limited to fixing that one specific problem, right? Even though that's a great example. The source suggests the capability is growing.
Yeah, they make it clear it's a foundational technology, and they're rapidly expanding what they can do with it, rolling out more applications across their network.
So beyond the collision checks, what other examples did they mention?
They briefly touched on a couple of others that show its versatility. One was human simulation.
Right, we mentioned that data source earlier. Using the digital twin to simulate and optimize the manual steps done by human workers. Why is simulating the people, not just the robots, so important here?
Well, it's crucial for several things. Ergonomics, making sure the jobs are designed to be safe and comfortable, minimizing strain. Efficiency, finding ways for people to do their tasks with less wasted motion, better workflows. Safety, identifying potential risks where people interact with machines or the product. And, as we touched on, maybe even for training, letting people practice new tasks virtually before doing them for real. It's about integrating and optimizing the human element right alongside the automation.
Okay, makes sense. And the other one was about maps.
Yeah, automated identification of maps of the surroundings from existing 3D scans for smart transport systems.
Okay, break that down. Smart transport systems.
Think about modern factories. They often use things like autonomous guided vehicles, AGVs, or similar little robotic carts that move parts and materials around automatically without drivers.
Right, those little automated carts you see.
Exactly. And those systems need really precise maps of the factory floor to navigate properly. So what BMW is doing is automating the process of creating and updating those navigation maps by extracting the information directly from the 3D scans they already have for building the digital twin.
Ah, so they reuse the scan data.
Right. It means they can potentially deploy new AGVs or change their routes much faster and make sure their maps are always accurate without needing someone to go out and manually survey the plant every time something changes slightly. It speeds up the rollout and flexibility of their internal automated logistics.
So the big picture here, the implication of having this robust digital twin platform built on tech like Omniverse is that once you've created this accurate dynamic digital copy of the factory,
I've essentially built an environment.
where you can develop new simulation tools, new optimization applications, and then potentially roll them out efficiently across many, maybe even all, of those 30-plus plants in the network.
Exactly. It's not just solving one problem in one place. It becomes a platform for continuous improvement and planning innovation across the board.
The benefits kind of multiply them.
They really do. A new capability developed and tested virtually in one plant's digital twin could potentially be deployed across the whole network much faster than building site-specific physical solutions everywhere. It really scales the value.
Which leads us nicely to thinking about the bigger picture. How does this specific BMW story connect to broader trends? And why, ultimately, should you, the listener, care about this beyond just, cool car factory tech?
Well, first off, this initiative is pretty much a textbook example of Industry 4.0 in action, or you could call it the digital transformation of manufacturing. Digital twins are widely seen as a core pillar of that whole movement.
How so?
They act as that crucial bridge connecting the physical world, the machines, the materials, the buildings, with the digital world of data, analysis, simulation, and control. They're what enable you to build smarter, more connected, more efficient, more flexible production systems.
And this BMW case really highlights the convergence of a few key tech trends, doesn't it?
Absolutely. It perfectly shows the power you get when you integrate. First, the ability to collect and link massive amounts of diverse data. Second, the power of sophisticated simulation to model incredibly complex real-world systems. And third, the growing role of AI to enhance the analysis and automation within that digital space. BMW is showing how putting those pieces together in a focused, industrial way unlocks serious value.
So let's bring it back to the listener. Why should you care about BMW industrializing and scaling its virtual factory?
Well, if you're a learner, maybe someone studying engineering or manufacturing, or just someone who likes understanding how complex things work, this is a fantastic, detailed, real-world case study.
How so?
It gives you concrete insights into the future of production planning, logistics, factory design, even the kinds of skills people will need in factories down the road. It shows how these sometimes abstract digital concepts get used to solve very real, very physical, very complex problems.
And what if you're just, curious?
If you're just curious about how things get made or how big established companies use cutting-edge tech to stay ahead, it's just fascinating, isn't it? Seeing how BMW is using these virtual worlds, this industrial metaverse, not just for designing cars, but for fundamentally planning how to build them more effectively.
And for anyone interested in the business side, efficiency, strategy.
Well, for anyone focused on business efficiency, operations, or how digitalization impacts traditional industries, those numbers we talked about are incredibly compelling. That projection of up to 30% reduction in planning costs, that dramatic time cut for collision checks, 4 weeks down to 3 days.
Yeah, those are powerful.
They're powerful proof points. They show unequivocally that digitalization, when it's applied strategically and scaled up properly, can unlock massive value and create a real competitive edge, even in really complex capital-intensive industries. It proves these aren't just tech buzzwords, they translate directly into tangible business results.
And the fact that BMW is actually presenting this work publicly at major tech conferences. You mentioned NVIDIA GTC Paris coming up.
Exactly. They're presenting there on June 12th, 2025, specifically focusing on accelerated computing, digital twins, and AI. That reinforces the idea that BMW sees this virtual factory as a major strategic, public-facing technological achievement. It really validates all the key themes we've dug into today: the power of simulation, the impact of digital twins, and the growing role of AI in industry.
Okay, so let's try to quickly summarize the key takeaways from our deep dive today. BMW Group is making a big strategic move, industrializing and scaling these digital twins for over 30 of its factories worldwide.
Right, making this virtual factory a core piece of their future iFACTORY strategy.
Their main goal is speeding up production planning globally, especially because they've got this huge wave of over 40 new vehicle models or updates hitting their plants by 2027.
And the projected benefits are really substantial, up to 30% lower planning costs and dramatically faster validation, like cutting those collision checks from almost 4 weeks down to just 3 days.
And it's all powered by intelligently linking tons of different data building layouts, machine specs, logistics flows, even human worker actions.
Allowing for these sophisticated real-time simulations inside an industrial 3D metaverse built on platforms like NVIDIA Omniverse.
And with a clear eye towards bringing in more advanced AI like generative and agentic AI in the future.
Yeah, it's really a prime real-world case study. It gives you a fast track to understanding a super important development in the auto industry, seeing exactly how the tough, complex planning for the physical world of manufacturing is increasingly happening first, faster, and much more efficiently in the digital realm.
And reflecting on all of that, especially that collision check example, automating and perfecting something so critical virtually before any physical disruption.
Yeah.
It does leave us with a pretty interesting thought to ponder as we wrap up.
What's that?
Well, if these incredibly complex physical processes, the ones that used to take weeks of real-world trial and error, can now be planned, tested, and perfected with such high accuracy and speed in a digital twin, what does that mean for the future nature of manufacturing challenges?
Interesting question.
Does it mean the hardest, most time-consuming problems in actually building things will increasingly shift away from the physical factory floor and more into the digital planning phase? And looking even further ahead, what happens when that digital twin gets so accurate, so comprehensive, so intelligent, maybe boosted by advanced AI that doesn't just simulate, but can actually find problems and propose optimized solutions on its own?
Could it potentially outperform a human planner who's relying only on past real-world experience, at least for certain kinds of problems?
Exactly. Could it? And if so, what completely new kinds of skills, what new expertise, maybe even what new ways of humans and AI working together? What will be essential for the planners, the engineers, the operators who run the factories of tomorrow?